जाएगा। तेईस अगस्त को जब भारत ने चंद्रमा पर तिरंगा फहराया, उस दिन को अब हिंदुस्तान नेशनल स्पेस डे के रूप में मनाया जाएगा।
The moon, a well-known visible object in the night sky, has captivated the minds of both scientists and common people. The charming allure of the moon has enchanted people throughout history. Scientists believed the moon would reveal the mysteries of the solar system and our own planet Earth. This mysterious puzzle has fueled numerous expeditions to our celestial neighbor. India achieved a significant milestone in space exploration when Chandrayaan-1 was successfully launched on October 22, 2008. The spacecraft carried a total of 11 scientific instruments. It orbited around the moon at a height of 100 kilometers from the lunar surface for chemical, mineralogical and photogeologic mapping of the moon. With the suggestion of former President Dr. APJ Abdul Kalam, ISRO achieved a remarkable feat by creating the Moon Impact Probe, which became the first Indian object to touch the lunar surface. This accomplishment is a testament to India's innovative approach and dedication to space exploration. The presence of water, H2O, and hydroxyl, OH, on the lunar surface was a groundbreaking discovery of the Chandrayaan-1 mission and opened up new possibilities for lunar exploration. The follow-on mission, Chandrayaan-2, was successfully launched on July 22, 2019 by the ISRO's heavyweight LVM-3 M1 launch vehicle. The Chandrayaan-2 satellite was made up of orbiter, lander Vikram and rover Pragyan. The orbiter is still healthy and continuing its observations about the lunar surface. The suite of orbiter payloads with unique capabilities is offering valuable insights into the lunar surface, providing a plethora of information to the scientific community and conducting a comprehensive analysis of the moon's topology. The Chandrayaan-2 mission paved the way for Chandrayaan-3's soft landing on the lunar surface. On July 14, 2023, ISRO's heavyweight launch vehicle LVM-3 M4 successfully launched the highly anticipated lunar mission Chandrayaan-3. The Chandrayaan-3 integrated module is configured with a propulsion module and a lander module with the rover housed within the lander. The lander module of the Chandrayaan-3 has been enhanced to ensure greater durability and resilience, surpassing the capabilities of the Chandrayaan-2 module. It has been reinforced to independently adapt to a wider range of variables, enabling a safe and soft landing. Detailed tests have been carried out for the performance evaluation of the lander systems on Earth to ensure the capability of lander for autonomous, safe and soft landing in all possible conditions. The propulsion module comprised a payload called spectropolarimetry of habitable planet Earth. SHAPE. This payload was designed to discover how smaller planets in reflected light would allow us to probe into a variety of exoplanets which would qualify for habitability. The lander module was equipped with 4 payloads, namely radio anatomy of moon-bound hypersensitive ionosphere and atmosphere. RAMBA was used to measure the near-surface plasma density and its changes with time. Chandra's Surface Thermophysical Experiment (CHAST) carried out the measurement of thermal properties of lunar surface near polar region. Instrument for Lunar Seismic Activity (ILSA) measured the seismicity around the landing site and delineating the structure of the lunar crust and mantle. Laser Retroreflector Array (LRA) was a passive experiment to understand the dynamics of the Moon system. The rover module was equipped with 2 payloads: Laser-Induced Breakdown Spectroscope or LIBS did qualitative and quantitative elemental analysis and derived the chemical composition and infer mineralogical composition to further our understanding of the lunar surface. Alpha Particle X-ray Spectrometer (APXS) determined the elemental composition of the lunar soil and rocks around the lunar landing site. The LVM-3 rocket successfully deployed the Chandrayaan-3 satellite into an elliptical parking orbit at a distance of 170 by 36,500 kilometers. Following the sequence of Earth burns or EBN, the spacecraft was precisely inserted into translunar orbit. On August 5, 2023, Chandrayaan-3 successfully entered the lunar orbit at an intended distance of 164 kilometers by 18,074 kilometers. Then the spacecraft achieved a lunar orbit of 153 kilometers by 163 kilometers through a series of lunar burns. On August 17, 2023, the lander module was successfully detached from the propulsion module. After a series of maneuvers, the lander module was successfully brought into a 25-kilometer by 134-kilometer lunar orbit. Consequently, the lander module initiated the power descent phase to achieve a soft landing near the south pole of the lunar region. Then, the much-anticipated spacecraft landing on the lunar surface had begun. On August 23, 2023, the long-awaited Chandrayaan-3 spacecraft achieved a successful soft landing on the Moon. The entire country witnessed the event and cherished the triumphant occasion. The entire nation was filled with pride as they witnessed the relentless efforts of the Indian Space Research Organisation. The Honourable Prime Minister, Shri Narendra Modi, witnessed the triumphant event through virtual mode and applauded the valiant efforts of the ISRO scientists.
चंदा मामा बहुत दूर के हैं, चंदा मामा बहुत दूर के हैं, अब एक दिन वो भी आएगा जब बच्चे कहा करेंगे चंदा मामा बस एक टूर के हैं.
On August 24, 2023, rover ramped down from the lander and India embarked on a historic moonwalk. After coming back from South Africa and Greece, the Honourable Prime Minister promptly headed to the ISRO Telemetry Tracking and Command Network (ISTRAC) in Bengaluru on August 26th. During his visit, he expressed his admiration and delivered a historic speech about the achievements of ISRO scientists and the lunar mission Chandrayaan-3. He also saluted the pivotal contribution made by the women scientists of ISRO, the Nari Shakti in the successful accomplishment of India's lunar landing mission. By achieving this historic feat, he has given it the names
चंद्रयान 2 के पद चिन्ह जहां है, वो स्थान आज से तिरंगा पॉइंट कहलाएगा। और जहां पर चंद्रयान 3 का मून लैंडर पहुंचा है, वो स्थान आज से शिव शक्ति पॉइंट कहलाएगा।
To commemorate the grand success of Chandrayaan 3, the government of India announced
23 अगस्त को जब भारत ने चंद्रमा पर तिरंगा फहराया, उस दिन को अब हिंदुस्तान नेशनल स्पेस डे के रूप में मनाया जाएगा।
The remarkable achievement of Chandrayaan 3 highlighted India's impressive technological advancements, scientific expertise, and unwavering dedication to the exploration of outer space. India's success will further strengthen its position in the global space community. The success of this mission will ignite a sense of pride and inspiration in future generations.
मंगलायन की सफलता ने, चंद्रयान की सफलता ने, गगनयान की तैयारी ने देश की युवा पीढ़ी को एक नया मिजाज दे दिया है। आज भारत के छोटे छोटे बच्चों की जुबान पर चंद्रयान का नाम है। आज से कोई भी बच्चा रात में जब चंद्रमा को देखेगा तो उसको विश्वास होगा कि जिस हौसले से मेरा देश चांद पर पहुंचा है, वही हौसला, वही जज्बा उस बच्चे के भीतर भी है, उस युवा के भीतर भी है। जब हर वर्ष नेशनल स्पेस डे साइंस, टेक्नोलॉजी और इनोवेशन की स्पिरिट को सेलिब्रेट करेगा, हमें हमेशा हमेशा के लिए प्रेरित करता रहेगा।
Today, and I'm truly honored to welcome you all to the National Space Day 2024 celebration. जहाँ चाह वहाँ राह, अंतरिक्ष की ऊंचाइयों को छूने का समय आ गया है। Where there is a will, there is a way. The time has come to reach the heights of space. As Prime Minister Shri Narendra Modi declared that August 23rd will now be recognized as National Space Day, a testament to India's growing influence in global space exploration. So today, we gather virtually to celebrate India's remarkable journey in space exploration, especially the monumental achievement like Chandrayaan 3, which have made every Indian proud. To mark India's historic Chandrayaan 3 moon landing, Space India organized several events on National Space Day conducted by space associated schools. So we have activities like student-led presentations and science fairs going on. We have students sharing their admiration for ISRO with photos and messages. And we have an interactive session exploring India's space mission in the form of Cosmic Mind Forum featuring Dr. Guvain. Thank you all for joining us and celebrating this monumental achievement. So, as we embark on today's event, our aim is to delve into the incredible advancement in space technology and explore the possibilities that the future holds. With the theme India's Space Saga to the Moon and Beyond, we will not only look at the scientific milestone but also discuss how these achievements impact our daily lives, inspire the next generation, and shape India's place in the global space community. Now, we are privileged to have with us a distinguished panel of experts who have dedicated their lives to advancing space science and technology. First of all, I would like to honor Ms. A. Dhanalakshmi, who is the Joint Secretary at the Department of Science and Technology. We also have Mr. Subhash P. Kuppusamy, the founder of Brahmastra Aerospace System. We have Dr. J. Patrick Miller, the Director of International Astronomical Search Collaboration. Mr. Siresh Palkonda, the Vice President of Business Development at Skyroot Aerospace. Dr. Rintu Nath, Scientist F and Division Head of Publication and Information System at Vigyan Prasad Department of Science and Technology. We also have Professor Sandeep K. Chakrabarti, the Director of the Indian Center for Space Physics. Yes, last but not the least, Dr. Sachin Bhamba, the founder of Space Group. Thank you so much, everyone, for being us with today. So, before we start now, without further ado, let's dive into our discussion. And I would like to invite our Honorable Dr. Sachin Bhamba to share his insight and vision for the Space India organization on this auspicious occasion of National Space Day, as well as his perspective on the past, present, and future of India's space sector. So,
Honorable panelists, organizers, and the people who are watching us today on India's first National Space Day, my congratulations to everyone in India. We indeed are proud today that we are celebrating our Space Day to commemorate what we have achieved through Chandrayaan 3, the landing to become the first nation to land anything on the South Pole or near the South Pole region of the moon. I think for me, this is a dream come true because space astronomy hit me very young. When I was a child, studying in class 8th, when I was shown a microscope and I was taught a telescope in class, and I asked my teacher, can I have a telescope also to view? And then I realized that my teachers were not technically ready, to make me see through a telescope. The astronomy and space science was missing from Indian education system. Later on, when I joined my MSc, there was an observatory in our university, Delhi University, which was built long back before I joined. But I again saw that observatory was not functional. And I'm thankful one of my teachers is one of the panelists today. And, he and Dr. Panchapakeshan helped us to open that observatory. So it was very evident that although, whatever we derive from nature comes from watching astronomy, comes from astronomy and space sciences, all the technologies that we have today, we in everyday life, we are using more than 25,000 spin-offs of astronomy and space. And today's space sector is doing wonders, where they are helping fishermen to find new fishes, where they're helping for navigation, then our television, then our mobile phones, and then our internets, and up to the chemical that we use in the nappy pads of kids is all that comes from spin-offs of space technology. But it was missing from our education system. I would say I'm just lucky, that it struck me very early, and somehow it became my mission. So I have never felt that I have worked in my life. So being a pioneer of astronomy, bringing astronomy and space education at school level, college level, it is easy because startups, incubation centers are now a talk nowadays. But to bring astronomy to school level is a different challenge altogether. When you have to work with class first, second, third class kids, then you have to think in a very different way. So when I was started, I was also young, and it was the time when startups were not known. So probably we are the first startup into astronomy and space education in India. And at that time, this ecosystem did not exist. So, it was very difficult. For first, you understand how to write a curriculum, how it could be meaningful for people at that age, for teachers, for school principals to understand why bring astronomy and space sciences at this early level. Although Twinkle Twinkle Little Star, How I Wonder What You Are is the first poem that we teach kids. And
Absolutely.
our curriculum at primary level says that the student should be exposed what they can see. So they have to understand what they can see. And space is all around us. They see moon, they see sun, they see stars, they see satellites, and they talk about aeroplanes and so on and so forth. And they obviously talk about rockets. But to make them understand what they are just simply reading in the book, that can be actually shown through a telescope. They can be involved into activities where they can understand what they are learning in science was a difficult task to start at that point of time. Also, when you are actually trying to do something which people are not yet ready to accept, the next problem comes from human resource. So imagine that if you are opening an institute where there is no other institute which is training people for you, and whoever you take, you have to train them into the technical knowledge of using a telescope and astronomy. As I said, that was not present at that point of time. So again, to first find your right people, then second, to train them, to make them usable for you for after 3-4 months of training. And then finally, you don't even find the infrastructure like books, activities, kits, models, charts, educational aids. So it was a complete ecosystem of education into space that we had to create. And it is easy to understand that you cannot go and buy these things. They have to be developed slowly. So ecosystem of bringing astronomy to schools was developed slowly. And astronomy needs three things always. One thing would be the skill and the education to understand what you are going to do. Then second thing would be instruments, and the third thing would be the place. So it is material, uh, then the product, that is education, and the place, which has to be important for any person pursuing astronomy. Because Delhi, let's say, living in a city, you will not be able to see stars as a field astronomer. You will have to travel to a location which is dark enough to make you see the deep sky objects. So this is how space group has slowly emerged. So first, it was education that we entered into. Then, there was a need for training people, so we entered into training. And then there was need for instruments, so we are into manufacturing. And then again, finally, the location. So astroport and astrotourism were the words that were coined by us long back in 2006. And since then, many historical achievements have happened within space. So we are kind of passionate people about teaching astronomy hands-on and spreading the scientific temperament, because we drive our mission from the fundamental duties of the written in the constitution for our citizens. So spirit of inquiry and spirit of inquiry and reform is what our purpose is. So projects like Khoj, where students were actually involved into going and finding the IST timeline physically. So it's one thing that you're reading about International Space Timeline, and it is another thing that you go and verify, not with a GPS system, but using simple instruments like gnomon rods to find your longitude and latitude. And this project Khoj was mentioned in Oxford University Press textbooks, and it was also written as one of the ways geography, longitude, and latitude should be, or these kind of concepts should be taught to students. So it has been a long journey, and then we took to do the first ever flight that studied first ever passenger flight done by any non-government organization in India to study solar eclipse. Then first ever cruise that took people to Indian Ocean to study the solar eclipse again. Then Helio DC, where students are selected through a competition and fully sponsored to cover solar eclipses with top-notch scientists. People like Sheridan Williams, Fred Espenak, they have interacted with our kids. And Indian scientist Dipankar Banerjee is one of the advisors for our solar campaigns that we conduct. And from manufacturing of a single gnomon is the kind of stick that you see in a sundial that stands straight.
Right.
to building an observatory that we have recently built with DPS Faridabad. It's a long journey that we have entered. So we are kind of a turnkey solution for everything. And all of this started with registering a organization called Space, which was initially a society. So it is Science Popularization Association of Communicators and Educators. The acronym Space was used. So purpose was to find funds to do activities, and there are huge projects that we do with our students. So whatever we earn in our for-profit ventures, it is dedicated. A handsome amount is dedicated towards popularization of science, particularly astronomy and space. So this is the complete scenario of what space is all about. So this is the thing. And since all of this has happened, uh, waiting that as the international celebration of World Space Week happens, for which I am also the national coordinator. I have been proposing many times there should be a space week at least, a day at least for India. And thankfully, last year, Prime Minister Modi announced it, and we are indeed, all of us are very proud that we are celebrating our first National Space Day. So,
Very, very true, sir. And thank you so much, sir, for your enthusiastic words and inspiring remarks. And we truly proud to be a part of space, and your input has been both inspiring and informative too. So I would also like to remind our kind audience that we have set aside time for Q&A session at the end of the discussion. Feel free to submit your questions through the chat, and we will address them later in the session. So, proceeding with the panelist, Ms. Thanalakshmi ma'am, coming to you, we would be glad if you could share your perspective on pivotal role in shaping policies within the Department of Science and Technology, and just let us know that how might the new space policy, particularly the new space policy 2023, influence India's trajectory in space exploration over the next decade. So, ma'am, your esteemed position, your insights will be like valuable in guiding us towards what the future may hold.
Thank you very much, Ms. Neha. And I would like to appreciate Mr. Sachin for his journey through the space sector. Entrepreneurs like him will certainly change and add a lot of value to the value chain presentation. So I would like to just have a small, brief presentation before
Sure.
I actually answer your question. So I'll share a screen with my presentation. So you all of these are all open knowledge, which I need not emphasize. Everybody is aware that ISRO was established in 1969 to harness the space technology for national development and social benefits. And ISRO has achieved significant milestones, including launch of India's first satellite, Aryabhatta, in 1975. Other than that, in 2013, India's Mars orbiter mission was also known as Mangalyaan, which made history by becoming the first interplanetary mission to be successful on its maiden attempt. Was done by ISRO, and this accomplishment showcased India's space power on a global scale. And Chandrayaan mission, all of us are aware, ISRO's Chandrayaan 1, 2 missions have contributed to lunar exploration, with Chandrayaan 2 specifically aiming to explore the south pole of the moon, covering new scientific insights. So, our satellite technology and communication has influenced several spheres of our life, like telecommunication advancement. India's space technology has played a pivotal role in revolutionizing telecommunication, enabling remote and rural areas to access communication network, thereby bridging the divide. Let me tell you one thing. Whenever I am in an international conference discussing about India, the entire world recognizes and appreciates our UPI technology, the way 1.4 billion people of India are able to make digital technology. This revolution through which we are being recognized as a power to be counted in the world is supported by these kind of telecommunication technologies. And Earth observation satellites have been, ISRO's Earth observation satellites have been instrumental in monitoring natural disasters. We have so many some of our climate observations, weather forecasts, are very precise. That's with the help of those Earth observation satellites and agriculture planning. One, in fact, 10 years back, I'm not talking the recent thing, 10, 15 years back, we had a project in which, with the help of ISRO's Earth observation, we mapped areas in UP and Uttarakhand, where in deciding which plantation can be very successful in a particular area. So we had crop mapped the entire area for agricultural purpose. And the resource management is we have and our watershed management initial strategy through these Earth observation satellites data. This kind of resource management, like, mitigation of natural disasters and agricultural planning, they have a lot of relevance to the rural and agriculture urban setup in India. Thereby, we can, plan sustainable development, which is more important. Navigation system, the development of indigenous navigation systems like the Indian National Navigation Satellite System has boosted India's autonomy in positioning the timing service, benefiting various sectors, including transport and disaster management. I'll be elaborating these areas in my further presentation. So, space exploration has also helped in advancement of astrophysics and astronomy, leading to discoveries such as thereby enriching our understanding of the universe. Space science research has increased a lot. The very fact that private sector players are interested in coming into space sector has been because of our space researchers, which have increased in its magnitude. Collaborative efforts with international space agencies have enabled India to engage in cutting edge space research, fostering innovation and knowledge exchange in areas such as space medicine, material science, and microgravity research. The space education and outreach program has also inspired and nurtured a new generation of scientists, engineers, fostering a culture of scientific curiosity and innovation across the country. And my predecessor, just the one who spoke just before me, he is one of the byproducts of this outreach programs, I think. So, social impact, any scientific technology will be successful only when it has an impact on the society. Only when your research from the lab goes to the field and the people are able to use those technologies, only then the money spent on those researchers get their value recognized. So crop monitoring and management, I think I have already mentioned about this. Satellite-based remote sensing has facilitated precision agriculture. Precision agriculture will always help in high yield, better resource management, and better water management, particularly enabling farmers to monitor crop health, optimize irrigation, and enhance productivity, thereby contributing to food security and increasing the livelihood options of rural people, thereby boosting the rural economy, which contributes a major part to our India's GDP. Natural resource mapping is also a spin off of this space technology. Space technology has been pivotal in mapping land resources. India has a lot of land issues. As long as a piece of land doesn't have much value, there is no dispute on that. Residential areas, agricultural areas, government possessed lands, so that these lands for better purposes. Soil characterization, I have already told how we have, analyzed the soil of a particular region and suggested crops which are best suited for that region. And water resource management, through these the information data, we have built check dams and watershed management programs have thrived over a period of last 15 years using these resources and data. This also aids in informed decision making for sustainable agricultural practices and particularly resource management, not only water, even efficient use of land, efficient use of pesticides, all this are governed under this. You know, disaster is something which is not man-made. Sometimes nature shows its fury without a warning. But human beings' resilience lies in, expecting those things. We are well prepared now. Early warning systems based on satellite data has boosted our disaster resilience. You won't believe the fishermen in the fishery, in the going for deep sea fishing, have a small equipment through which they get information about cyclones and high speed winds so that they can return back to their station, return back to their landing place early in time to avoid loss of material and net. These disaster resilience system based on the space data provide timely alerts to flood, drought, and cyclones. This minimizes agricultural losses and safeguard livelihoods of people. More than everything, the human values, human life is being protected by this. Climate monitoring analysis satellite observation has provided crucial data for climate monitoring, weather forecasting, environmental impact assessment, thereby supporting climate research, disaster reduction, and sustainable development. The government of India has included a new supercomputer to be department which is monitoring our climate, which is forecasting our weather daily. So we will be able to now have a better information on the better focus on our weather climates. Regarding biodiversity, India has a wide range of biodiversity, but we have to map it and then we have to facilitate these people who are doing research on our biodiversity data. We have to monitor habitants and we can also assess the ecological impacts contributing to conservation efforts and ecosystem management and wildlife protection, particularly, can use these data. Pollution control and urban planning, you won't believe the problem, particularly when you live in Delhi. If you have come from a very remote or rural area, and if you have recently shifted to Delhi, you can understand how much your lung is crying for a fresh air and fresh, pollution-free environment. So the satellite images have facilitated pollution monitoring and urban planning. Recent times, we are used to a phenomena where building constructions are banned, pollution creating activities are banned. These are based on these satellite imaginary data. And national resource conservation is, a byproduct of our data management, enabling evidence-based policies for pollution control, sustainable urban development, and ecological restoration. These are some of the spin-offs of the spatial data. Regarding education and skill development, STEM education and outreach programs are inspiring students and educators through space science programs. Astronomical clubs are established all over India, and educational satellite projects are nurturing scientific curiosity and innovation. Let me tell you some of the programs which Vigyan Prashad has and Department of Science and Technology has for this kind of STEM outreach program. In Vigyan Prashad, we have provided telescopes to a lot of schools, government schools and colleges, through which the students of those schools can be sensitized regularly on astronomical events, astronomical activities, and these students can use, as the one who spoke before me has told, this is a rare resource which has to be shared by the schools and colleges with the common public and students so that they can nurture the interest in astronomy and space sciences. Apart from this, we have astronomical societies all over the country and we have memberships, and these societies forecast the events. We keep conducting events like the National Nose Shadow Day. We keep creating awareness on the solar and lunar eclipses as and when it happens. Regarding skill enhancement and entrepreneurship, as the person who spoke to me before me told, human capacity building in the field of space has been limited to government initiatives. These government initiatives are restricted to ISRO or astronomical institutions. But that will not suffice, because unless you build a capacity of human resources who can train, there should be some kind of trainer programs which can spill over to other smaller rural areas or urban centers, from where children can get a lot of information about the technologies. So entrepreneurship and skill enhancement is also a spin-off of the space industry. It provides skill development, attention, technology innovation, fostering a culture of research and development, contributing to economic growth, not and technological self-reliance and awareness among the youth of the country. So, youth engagement and inspiration programs have outreach activities and engage youth in scientific pursuits, exploration, and space entrepreneurship through fostering a new generation of space enthusiasts and innovators. And we'll have more such in our future. So, satellite internet and connectivity advancement in science in these areas have revolutionized digital connectivity, bridging the urban-rural divide and enabling universal access to high-speed internet and digital services. In most remote part of the India, where electricity has not reached, mobile phones has reached. People earlier were economic development has been a spin-off of this connectivity. In rural areas, people who have lean season and who could not work during period when there is no active agricultural activity, now they migrate to the nearby urban area because they have a connectivity with their family back home. They can call up in case of emergency, the family which is left behind at home. This has revolutionized the kind of employment scenario in the country. Smart agriculture and integration of space technology with IoT and precision agriculture is set to enhance agricultural productivity, which I have explained already, resource efficiency, farming practices, and food security has increased over a period of time. Interplanetary mission and space telescopes and space science research is supposed to unlock new frontiers of knowledge, cosmic exploration, and scientific discovery through research and collaboration. Space debris management is a big challenge. As on today, we are doing the space activities in a smaller scale. So, as on today, it may not have a big, significant influence on the environment. But over a period of time, when all our activities increase, when we open up through the new space policy, when we open up the activities for public-private partnership area in PPP mode, then we may have to manage this space debris, and we have to ensure sustainable and safe faring practices in the space. With this, space diplomacy and global governance will also increase. Ethical consideration and space security will also increase through the new space policy. Thank you very much. Now, I'm ready to start the panel discussion.
Yes,
I hope
ma'am.
this information was useful for the students
Truly.
who are connected with.
Sure. Yes, ma'am. We are truly grateful for your insightful remarks. At the Joint Secretary, your leadership is instrumental in guiding the Department of Science and Technology towards new achievements. And we are confident that your vision will inspire the development of innovative strategies to advance space science and astronomy among the public. Now, coming back to the discussion, Mr. Kuppusamy, the founder of Brahmastra Aerospace System, with the context of the views shared. Hello, am I audible?
Yeah,
Yeah.
you're
So,
on.
Yes,
Yes.
you are. Yes, you are.
Yes. So I'll just repeat. So Mr. Kuppusamy, the founder of Brahmastra Aerospace System, with the context of the views shared by ma'am, what do you think about the celebration of National Space Day and how it can inspire young minds to pursue their careers in space sciences and technology?
Very good morning, and thank you for the question. Good morning, ma'am. I'm Subhash P. Kupusamy from south part of India. And as Sachin Bamba sir said, his perspective about the astronomy, mine is different. I came from an aerospace background. I started my life as an intern in HL, where aircrafts, it is not aircrafts, it's warcrafts are made, right? So from there, I started to love toward the space. I wanted to make machines that go to space. That's how I started, right? So this National Space Day, which is I wonder about the West. Like they used to celebrate. Why are we not celebrating? And this is the right day we are starting. This is the first day we are starting. This makes the government, the students, the enthusiasts, the industry, the technocrats, bureaucrats, everyone on the same platform to make sure we are dwelling towards the antariksh, right? And yes, I feel so happy that everyone on the right platform so that we are going on the right path. That's it.
Thank you so much, Mr. Kupusamy. And along with this, I just need to know, in your opinion, how can educational initiatives across India be strengthened to keep pace with the rapid advancement in the aerospace sector or in the space sector, depending upon your background? I'm just asking.
Yes, it is a cross funneling thing. Like we have to do the things side by side. One side, we are on the track of space privatization, which has opened a big gate to the private players in India. That is going to be the big thing in the next decade. So if it is going to be the next decade a big thing, there is a big skill gap we have to address, right? In terms of skill gap, we are opened the ISRO's data access, like in order to process the weather monitoring, weather forecasting, and then you know the land side things. All these things are monitored by ISRO. Now it can be monitored through the raw data can be accessed by the private space sectors as well. But the startups has to come up, right? So these things now we have to work on the school level, we have to work on the college level, so that the skills are addressed. And this once the skill are addressed, it has to address the policy and the initiatives taken by the government. So once all align at the same line, we are heading towards boom.
Okay, so we are grateful for the clarity and depth of understanding you have brought to this topic. Thank you so much. It was really
Thank you.
incredibly enriching. So, someone who has made significant contribution to global astronomical research. Yes, I'm talking about Dr. Miller. So, Dr. Miller, so my next discussion is with you only. We just need to know, even our audience need to know, how do you view India's recent achievement, such as the Chandrayaan 3 mission, in the context of the global space exploration landscape?
I think um, I think it's very exciting what's happening, particularly some of the discoveries that have been made recently from the lunar South Pole by your spacecraft that landed on the surface. I started in astronomy many years ago, but at the time of Sputnik in 1957 is when I became interested in astronomy. The Russians launched the first satellite into space a few months before the United States did. And I remember going to the local drive-in movie theater and watching Sputnik and some of those early satellites passing overhead. Now, if you walk outside and look, you see them every few minutes. Or if you see the Starlink, you see them by the hundreds. So the work that India is doing and what was described there about the privatization of space is going to provide a revolution in the industrialization of space. You listen to spacious space for commercial purposes, including recreational purposes. We see a little bit of that now with non-astronauts going up and on spacecraft to the edge of space. Pretty soon they'll go up and go in orbit around the space and probably be staying in hotels and recreational facilities that are built specifically for that purpose. So I think that the work that India is doing, the work that China is doing, the work that the other nations around the world have been doing will play a pivotal role in the privatization of space and our expansion and understanding of the solar system.
Okay. So we sincerely appreciate the valuable insights you have provided, Dr. Miller. So we also need to know, as being the director of International Astronomical Search Collaboration, how important do you think such partnerships are for India's continued growth and success in space sciences, Dr. Miller?
Well, the International Astronomical Search Collaboration, which we call ISIC, is a program that reaches over 10,000 schools in something like 180 countries. That represents about 70,000 students who participate. And what they're doing, and this is also true with the program we sponsor through space, is that they are searching for and making original asteroid discoveries using data provided by some of the sky survey telescopes around the world. In particular, the ones located at the University of Hawaii Pan-STARRS 1 and Pan-STARRS 2. When space goes out, and as I think you're now something like at 1,000 or 2,000 schools a year, that's an incredible achievement. And when you go out and you train the children to participate in this program, and then they come in, they actually make these discoveries. That inspires them to learn more about astronomy. It inspires them to want to make these discoveries. And in fact, there have been many discoveries made, and some asteroids that have been identified and numbered by students from India because of their involvement with space. So that's how I see this part of STEM, and that's how I see that involvement precipitating throughout your country and managed by your organization, which just does a fantastic job of organizing those annual search campaigns.
Yes. Thank you so much, sir. Your unique viewpoints you offered have greatly enhanced our conversation today. Thanks a lot, much appreciated. So, coming to Mr. Palikonda, the Vice President of Business Development at Skyroot Aerospace. Sir, it's just on the basis of the recent scenario that happened. Could you provide us with an overview of what happened during Sunita Williams' recent mission that led to her being stuck in space? So, could you kindly let us know that what exactly happened and how did the ground control and mission team manage the situation? So we just want, and our audience just want that little insight about the same. Mr. Palikonda, you there?
I was on mute, sorry.
Yeah.
So good morning, Dhanlakshmi ma'am and Dr. Sachin and Mr. Patrick and rest of the other panelists and the audience. And I'm indeed, thank you very much to be part of this particular program, the first National Space Day, what we are celebrating. And I represent Skyroot Aerospace, and Skyroot is one of the leading private space launch vehicle companies from India. And we are developing the launch vehicles with a vision of opening space for all. So we named our launch vehicles as Vikram, named after Dr. Vikram Sarabhai. So this Vikram series of launch vehicles can carry payload from 200 kilograms up to 1 ton. And indeed, we are one of the first company from the entire Asia Pacific to launch a rocket to space, and that we achieved with our Vikram S suborbital launch vehicle in 2022. And we stationed in Hyderabad with our headquarters and other 5 facilities in Hyderabad and with more than 300 people, and so far raised $100 million in capital. And we are actively recruiting people for our future missions. And we are moving towards our orbital launch towards the end of this year or the early next year. So this would be going to 500 kilometers of altitude, and it's a commercial launch with several customers on board. Okay, so yeah, being the brief context of where I'm coming from. Also would like to let all the audience know that as we are actually recruiting, if somebody is interested, they can apply it to this Skyrit. And now getting back to the question, like Sunita Williams being stuck in space. Okay, so yeah, first of all, like being in space for such a long time will have several implications on the physiology of what we have, and it is very unfortunate. Like the Boeing capsule is stuck there. However, like we need to understand the alternative ways how we can bring her back. But even if we see the recent art trend, what he mentioned is like it would be the happiest place for Sunita to be there for some time, and it is safest place. Okay, nothing to worry. Even before to this also, there was some who have been there for more than a year. Okay, so there is nothing alarming or concerning as we read everything on the media. Okay, and apart from ground stations and other things, probably I would not be the right person to speak on. Okay, so I leave it to the panel members, yeah,
Yes,
who can
yes.
answer the
So we
question.
have, yeah, we have Dr. Sachin Bhambar to share few of his, insight
Yes, yes.
related to the question. So Sachin Bhambar, sir, carry forward to the
No,
same
no,
field.
I do not want to answer the question. It was wonderfully answered by Suresh. I would rather
Yes.
ask a question to Suresh. Suresh, you are one of the organization who is pride of India now. Having the first startup and making Skyroot and making a rocket and launching, it's a dream come true for any child. And I know, since I still at 50, I feel like a child. So you must be kind of, so happy about what is going on. So. I just wanted to know how was your journey about, how did it all start? How did you think about it? And what future do you see for, other players who want to actually come into development of rockets? Is there a possibility? What are the possible things that can be done? And I have just two specific requests. One is, give some space to our kids. They would like to fly something in skyrocket. We can do a competition kind of thing, and a little bit of payloads can be taken by your rockets for school students. I would love to have that opportunity from you. And second is that whenever you launch, I would love to be part of the people in the audience gallery. If you can send an invite, thank you so much.
Yeah. Thank you, Sachin, for that question. So to uh, speak about our journey, we started in 2018. So we are quite an young company. It is just 6 years that we started. And the founders of Skyroot Aerospace are Pawan Chandana and Bharat Daka. Both of them were previously scientists at ISRO. And they have come out of ISRO and started Skyroot Aerospace. And today where we are, okay, with the launch and coming up with an orbital launch. So one of the challenges, like for any startup, if we see, there will be three major things. One is the technology. The second one is the regulations. The policy has to be there, and the third one is the finances. But fortunately, in India, for any space startup, ISRO has established significant infrastructure. So, one of the reasons for us to be in Hyderabad is because most of the components for the launch vehicles are being developed in Hyderabad. And also, we have so many DRDO labs and everything. So the test facilities and everything are available here. So being a startup, we need not develop everything from scratch, but we can utilize the facilities which are already existing. That comes as a plus point. And the vendor ecosystem, which has been developed by the ISRO for the last 60, 70 years, are really helpful for us. And they've been quite pivotal in our journey so far. And next, coming to the funding, okay, no investor would not feel very confident or secure if there is no policy in place. But when we started, there was no policy in 2018. But however, with the leap of faith, the investors has taken that step. And also our initial investor, if we see, they also have to share the common vision. And definitely I know about space. Space is indeed one of the oldest, institution in the entire space sector from India. And, forget about the sustainability, but how you guys have really survived is quite commendable. And, for a sector such as this, investor coming without any regulation or the policy in place, quite difficult. And we are fortunate enough that the government has come up with a policy on this one and also established InSpace. Now InSpace becoming the regulatory authority. They are supporting on several aspects of it. And one of the most important thing is ISRO being, very open about it and welcoming the startups and encouraging the development of them by opening their infrastructure and also the technology. Now ISRO is offering, a lot of its technology, including the launch vehicles and the satellites for the startups. Okay. Startup can use the technology and develop the whole thing. You don't need to reinvent the wheel. We can just accelerate the whole process and we can commercialize that. And also we as a launch vehicle company, we utilize the entire test facilities on the launch pad from ISRO. And having this policy coming into place, it has infused quite a lot of confidence into the investors, and that really helped not only us but many other startups. If we see the last year, the Indian space ecosystem has raised something like $150 million. That is quite significant. And also we have more than 250 startups already registered with InSpace and which are very active. So I can confidently say that we are going in the right direction, but that is not enough. There need to be more companies which have to come up. And there is a lot of demand, okay, with respect to launch vehicles. We just don't need to see the existing market. What I mean to say is, if we look into the roadmap of India, by 2040, we want to put a human being on the moon. Okay. If that need to be done, there need to be a lot of access to space is required. And it's not just India, but it is Europe, US and China. Everyone is doing it. And what about rest of the world? Even they need access to space, and it has to be done through somebody. And, we establishing as in, the front players, we can definitely utilize this opportunity.
Thank you, Sudesh.
Thank you so much for sharing your wisdom and for the impactful observations you have made. Much appreciated. Thanks a lot. So, coming to Dr. Nath, Scientist F and Division Head of Publication Information System at Vigyan Prasar. Sir, my next discussion, discussion is with you only, and our audience also want to know that reflecting on your work at Vigyan Prasar, how do you envision the role of science communication evolving in India, particularly in the context of promoting space science and technology?
Okay. Say we have touched the moon, we have interplanetary mission. Maybe in near future, we'll also have a deep space mission, and all these while touching lives. It's very important to understand the role of the people in development of anything, let it be space technology as well. See, appreciation of science in general is required for the whole nation to come up to at certain stage. And this appreciation for science starts at very, very early stage, at maybe a middle school level, at higher school level, how you are taking science so that you have the aspiration to be part of a national goal. So there are ways and means to do this. See, for example, for middle school and for senior secondary schools, it is not only that, curricular based, is the everyday incremental model of doing things hands-on. Apart from that, you need events, success stories, Events like successful landing, soft landing of Chandrayaan-3, events like maybe even eclipses, these are those catalytic events which is important to take to the masses and involve students in those events. Otherwise, it is everyday, curriculum, everyday's, laboratories, and everyday's, work which goes on. But whenever you are able to capture those, time and events very successfully, you get hold of those, minds who are very curious, but at the same time, they know their involvement and what they can achieve with that. For that, the workshops, conferences, seminars, apart from that, you have to have hands-on experiments, you have to have means and modes to do that and to reach out to the people. As Dhanlakshmi ma'am already said that, the schools, if they have, astronomy clubs, if they have a small telescope even, you can build up those, activities around those events. Maybe an eclipse event, maybe, successful launch of a satellite. All these events can be, captured the minds of the students who are bright enough and want to take part of this. Space is a very big, event. It's you need different kinds of expertise in that. So even if it is a space technology, unless you have a mindset of, knowing that, domain expertise, you have the domain expertise, only talking about space science or space, research is not going to take, you will not be able to part of that. You'll be only the end user of that. But what we need more bright minds to come up with the definitive idea of contributing to this space science. You are mute, I think. I'm not able to hear you. Neha, you are mute.
Yes, I'm really sorry, sir. Sorry for that. So, we are fortunate to have had the opportunity to learn from your experiences and insight. Along with this, given your experience, in developing innovative science experiments, what do you believe are the most effective ways to engage students in space science education and inspire the next generation of Indian scientists?
Initial period, I was engaged in data acquisition system. That data acquisition system is actually, you are taking data from the environment, different sensors, and taking action on that. Based on that, it's for development of, different projects and turnkey projects. In fact, I visited ISRO science centers also, and interacted with scientists. See, if you see that the pattern which 10 plus 2, K plus 12, K plus 2 standard in other countries, in developed countries, they do have those data loggers. They give it to the students, and they do, collect data and analyze data, which I have not seen many places which is in used here. What I am trying to tell that you need to understand that if a rocket is going or a space shuttle is going, it depends on many external factors. So you have to have the sensors and you take decision. So once we give that kind of approach, once we are able to show something like a kind of a data logger, where students are able to use it, they are seeing the data and analyzing the data and taking a feedback and giving a feedback controller, maybe based on something, maybe a temperature is increasing and you are shutting off a motor. These kind of feedback things, it works wonder. If a student is able to perform those, it's not always robotics. I've seen that, it's been done in many schools. They do the robot control things, which is, is a one-way communication. It's not two-way communication all the time. But and it's not many data. It's not multiplicity of data. You have to have parallel, at least 8 channels data to work on, and which is very simple, which, even if it is looking like a very complex system of having 8 channels data and analyzing it and coming up with a feedback mechanism, actually it's very, very simple. Vernier is having the system. In fact, in Big Gun Processor, we developed a system where 8 channels data loggers were developed. We had to have the data from different sensors and taking decision based on that and giving a feedback system. And this technology was transferred to Trinity Microsystems. In fact, 5 of the IITs, they had that data controllers, and they did many field trials with the students. So what I'm trying to tell, these kind of activities should be more predominant, very definitive things to go to the schools, colleges, and those, science centers, space centers, space, clubs, to have an understanding of how to work, and ultimately that that can to ultimate go to the further research in space science and further R&D research and development as well.
All right. Okay. Thank you, sir, for making the discussion so rewarding. It was so insightful, and we much appreciate it. So, coming to Professor Chakraborty, the director of the Indian Center for Space Physics. So, we just want to know that you were the first scientist to suggest that gamma ray bursts are the birth cry of black holes way back in 1995. So, what was the reception to your suggestions back then? And did it change in 2013 when scientists observed conclusive evidence of this? So, we really need insight related to this. Hello, Mr. Sandeep Kumar Chakrabarti. Sir, you are on mute. Hello, sir, you there? Okay, so I guess might be sir is having some technical glitch. So we'll just carry forward the discussion, and Dr. Ritunath will not pass on the question, but I hope if you can have some answers related to that, to the questions of futuristic plans and goals of the students related to the same thing, like experience in developing innovative space sciences experiments. And along with that, what is your like idea of celebrating National Space Day? So what are your thoughts on the impact of such observations on the fostering a scientific temperament among the youth, and how can we leverage these occasions to further science education and awareness?
Yeah, before I answer, I can see ma'am, Dhanlakshmi ma'am, there is a raised
Yes.
hand. So,
We can see
I'll take up definitely your question, but I will
yeah,
let Dhanlakshmi
no
ma'am
problem.
what she wants to share.
Yes, and meanwhile, I can see Sandeep Kumar Chakrabarti is also with us. Sir, you are on mute, sir. We just request you to please unmute yourself. Dr. Sandeep, sir. Professor Chakrabarti. Okay, so Dhanulakshmi ma'am, coming to you.
Yeah,
I
I
guess
think
you
my
want to say
Ritunath
something.
giving
Yeah.
his answer before me because I'm just going to add on
Okay.
regarding involving children from the inspiring children in the field of space and astronomy.
Yeah.
Like last year, we had a festival called India International Science Festival. Every year, we used to create a Guinness Book of Record, but last year, we took a conscious decision. Instead of somebody else validating our technologies and our initiative,
Hello.
we create our own records. Yeah.
Hello, can you hear me now?
Yeah, I will let him to
Yes.
finish before I continue.
Yes, Sandeep, sir, you are audible, sir. So just after Dhanulakshmi ma'am, we are coming to you because ma'am is just in between the information that she need to pass on to the audience. Yes.
We have an annual festival called India International Science Festival, which will be conducted in the month of October this year. So last year it was in the month of Jan. So what we do, we have created our own challenge. Instead of going to Guinness Book of Records, we have created an IASF challenge. And last year, we gathered around 50 children from various schools. I think 500 children from various schools. We gave them a kit with those kids, under supervised assistance from the senior scientists, they developed small model satellites and they launched it themselves. And these satellites went up the sky and they sent data about the weather. Now,
Great.
by this doing this, we have created a lot of interest in the children and we have given them a small model to handle which will make them more comfortable and convenient in furthering their interest in this technology. Apart from that, for the college going students, engineering or whatever degree or undergraduate or postgraduate students, we created an IAS challenge. In this challenge, we put them in a comfortable accommodation for 36 hours continuously. And we gave them 6 challenge questions on space sector. And we requested them to find solutions to these problems. Within that 36 hours, it was a marathon, continuous, without any break. They were not allowed to come out of their area. We were providing all the facilities required for them to stay within that space for 36 hours, but concentrate only on problem solving regarding space technology. And you won't believe some of these solutions which they brought out are much beyond the reach of our regular scientists, space scientists, because young mind has a lot of innovation. And when you have a small, push up, when you give them a small initiative or help from the department, they come out with so much innovative solutions which are far beyond the reach of regular scientists, because we have a straightforward, straight jacket approach to issues. But these innovators have variety of approaches. And these are the two information which I'd like to pass.
Yeah,
And
yeah.
I would like to add that the new space policy is emphasizing on public-private partnership. So all these small organizations who are struggling for validation, who are budding, aspiring space startups, they'll get a lot of boost now with this.
Yeah.
Thank
Thank
you.
you so much. Thanks a lot, ma'am, for your insightful perspective to the discussion. Now, coming to Professor Chakrabarti, sir,
Yeah.
the
So,
director of the Indian Center for Space
all
Physics. So,
right.
sir, yeah, I'll continue my discussion with the same question that you were the first scientist to suggest that gamma ray bursts are the birth cry of black holes way back in 1995. So, what was the reception to your suggestion back then? And did it change in 2013 when scientists observed conclusive evidence of this?
Okay, let me tell you something that about my background. It is not that the only gamma ray burst, but I have been working on the black hole accretion to DNA molecule formation during the star formation, etc. And all of them are cited last 40 years. And
Great.
I am sorry to say that most of the citations are mostly from people outside India, because the Indian people's framework or the mindset is still a little bit different. Now, I'll come to a little bit straightforward in the fact that my education from India as well as abroad is, I am very much blessed that I was the first class first in Calcutta University. And then, of course, I went to University of Chicago, then Caltech, NASA, Goddard I worked, and I worked at the DST Institute also for 20 years. And then ultimately in 1999, during the process, I created a new institute, Indian Center for Space Physics, of which I am the director. And this institute, Indian Center for Space Physics, has its own space program. We have already sent stratospheric balloons for 114 times. We have sent payloads, and those payloads get data, and the people are writing PhD theses on those data, our own data. We did not register yet with INSPEC or got any money or took any money from ISRO so far. So our experience is a little bit different from the rest of the people. Now, one of the things that I wanted to mention about that what the students should do, that they should first think about fundamental 4 pillars of science. If they really want to contribute to anything, they'll have to learn mathematical physics, the solid state physics, the electromagnetics, and classical mechanics, and cover to cover. I myself never went to a private tutor, cover to cover, and that is one of the secrets why I ended up, supervising 60 PhD students who are now faculties in PIFR, in IISc, and even in ISRO, a half a dozen of them. So why I'm telling this is that the making payloads, startups, and all these things are very fine at a very young age. But if your fundamentals are not strong, you won't be able to create a contribution which is above average. Okay, it will be, number will go up, but you will not be visible from far. Okay, so India is doing a lot of things. DST, we have heard that DST has spent a lot of money, but in our case, entire world actually are using our citation. As you know, that Stanford University list, I am the topmost astrophysicist every year. So obviously citation is very large, but this citation H index is 57, which is also the highest in India. But the point remains that the mindset, the fact that in many of the institutions, there is a Guru Shishya Parampara, that what Guru knows is the purple is to student, and student becomes the faculty, and faculty has his own student, he becomes the faculty. So that way, the opening of new ideas, anybody coming up with brand new ideas are not welcome. This I have seen from my own experience. One of the reasons why I founded this institute is that nobody can stop me from going to space or even to make a rocket. We have already tested rockets which are successfully, and we will also have launch pad someday. But the point is very important that try to think independently, trying to stay strong, independent of what your innocence may be lost at your very early age. You may be thinking that at this age that you will become an astronaut, which is absolute nonsense. I don't want to talk negative, but remember that entire mankind, we have only sent 12 people to moon so far. We have 8 billion people on the earth, and last 60 years ago, only 12 people went. That's it. So it is not, don't go beyond practical the dreams and what is achievable, what is doable, and stay within the parameters so that you don't get disheartened, your innocence is not lost, So that way, you will get negative things all the time. A lot of people feel insecure, mostly mediocre people will feel insecure because if somebody comes a new idea, he has to appreciate it, he has to make a place for you, and that place may challenge his place. So, or his or his Gharana's place. So I am saying that India has a long way to go. Mindset has to be changed. That's a different discussion. We can come at the back. But my feeling is that we are quite successful. We are the first startup in India, private sector, 1999. This year, we are celebrating Silver Jubilee. And at the same time, we have already sent stratospheric balloons 114 times. We are creating our own balloon facility about 200 kilometers from here. We have the largest optical telescope in Eastern India. But again, we are doing it quietly, and there are funds always. That India is not poor country. If you are really can convince people will give funds to you. And so I suggest that people should do their fundamentals. They should know what they are going to do. They should have conviction, and they should just go ahead independent of what government organizations, whether they support or don't support, doesn't matter. Okay, so I'm not very optimistic at the time being, but this situation has become better after Chandrayaan landing. But then it may be that we are wrong. The kids are getting highly excited, and we don't have so many takers. In the long run, if we have too many private sectors who are going to send satellites to space, do we want to send any odd junk to this space? Are we going to make this crowded? Already there are 10,000 satellites, 4,000 are active, 6,000 are debris non-active. We have to remove them. So I'm not very optimistic yet, but I'm very happy that the India is progressing in the right direction, albeit the speed is low.
Okay, thank you so much, Chakrabarti ji. Now, I guess Dr. Sachin Bhamba wants to share something over the views shared by Dr. Chakrabarti. So, over to you,
Yeah,
Sachin Bhamba, sir.
yeah. Hi, Professor Sandeep. So, I just wanted to add something to what you have been saying. Rather add, I would like to request you to change your perspective about India completely, because I can understand your frustration where it is coming from. Because in space education sector, I also felt for a very long time that there was no help. But I can assure you, the kind of changes that are coming today. So I'll answer both. I'll have a very different perspective of what you have. There is a complete structure available now. India did not have a space policy. As an individual player, it is not possible for me or you to have a space launching system, because states are responsible for private individual actions for a particular nation. But if you talk to ISRO and in space now, it is a complete supportive environment. Think where India, we always had regulatory authorities to tell you not to do this. So now there is a regulatory authority which not only holds your hand to whatever you want to do, but also creates possibility. You just go and request, you tell them you want to do this, and they will always be of supportive, not only just to people who are known or who are young, but to organizations like you and me. There is a complete support available, and it has changed my mind completely. So I would request that just reach out and you will find that whatever dreams or whatever possibilities you have for your students and for your institution, it will be highly supported by ISRO in space. And I have seen a complete change in perspective in the past 4 or 5 years as soon as this policy has come. The other point that you said, that igniting young minds and making them too demanding is a negative thing that can happen to a society. And you quoted that there are only 12 people who have gone on moon, rather 16 who have gone on moon. So I would say that people really do not want to go to moon. It is the opportunity that space sector offers. Even traveling in space, being space travelers, or maybe going to international space station, doing their experiments while being on Earth, is a huge possibility now. Skyroot has just recently signed an agreement with school students, where they can send their payload. So the private sectors are coming up, opportunities are opening up, and I'm sure with the kind of facilities that you have, there is a lot of possibility for students to actually work with your PhD level students in sending their payloads to the stratosphere using your balloon launching permissions and facilities. So I think there is a collaborative thing coming up. And on a National Space Day, the best thing would be that, we start believing in the system that we have all brought to this change. And I'm sure you are one of the pioneers and instrument people who have actually initiated these thoughts into the young minds and young people who are now at policy making. And in space, and the space policy that we have is a wonderful initiative already done. So nice to have your ideas, and this is what I wanted to submit.
Thank you so much. Coming to you,
No,
only
he would like to say something. Yeah.
Yes.
Yeah, actually, I am not frustrated. Quite the contrary, I like that the standard of science itself to be much higher at the level of NASA or Chinese agency or JAXA, something like that. You can produce infinite number of people at the ground grassroots level, but if your goal, suppose you want to make a science policy of 2047, your goal should be that we want to produce 4 Nobel laureates. That's the first policy. Now, to do that, what is the vision? Now, will vision of this vision be created by the people who will be sitting in the agency or the Prime Minister's office? If you give it to the agency that you make your own goal and reach there, they will clearly make the goal at such a low level, they can achieve and get the accolade. But if you make it totally independent, unbiased, and raise the standard and keep them shut down in a room for a month, say, boy, you come out with a recommendation and all the agencies are bound to listen to you. So choose the people who are competent, who have done science, and raise the level. Today, nobody talks about the fact that we have no Nobel laureates, no great researchers or the accolade from international. So first talk about, when you talk about the science vision, let us start with that. That let us have within 25 years, our goal is to have 4. I will tell you the James Webb Telescope, the PI, John Mather. He was my colleague at NASA. When I have been inviting him to India, he said, no, I am not going to India till I launch this James Webb. In fact, I can tell you it will produce at least a half a dozen Nobel laureates. So that is the motivation, the quality, the standard. India is always worried about the heritage. They want to preserve the heritage, and increments is very slow. But other places, they want to take risk, and their risk pays off. It is not that we are spending less money than NASA in terms of GDP. We are spending 0.4% of GDP. NASA is also spending 0.4% of American GDP. So issue is the standard of science must be raised. Of course, the number of people is very large. The number of people will become large statistically. That is not a problem. Problem is how to raise the standard, the goal, where we must reach within, let us say, another 25 years.
I think we can have a separate discussion. I would request organizers to have a discussion on this later on. I think that would be the best way of changing the minds of each other. And we appreciate your point, sir, and it will be very well taken. Yeah, thank you, Neha.
Yeah, so I guess Dr. Ritunath and Dr. Kupusamy also want to share their views. I guess we need to carry forward the same, or you need to share your insight over the same discussion which is going on.
Yes. So, Sandeep Kumar sir, I accept your whole perspective 25 years back, sir. Now we are on track. Now the private partnership and the public partnership and the government we are all on the same page and we are working towards what you are speaking, sir. We are already started. We already started to launch our private space agencies, right? Skyroot has launched their first rocket, right? And then the startup from Chennai has already done their maiden launch. We are on the track, sir, right? Like, sir, it is, you're saying that we are not US, sir. We are India. We need heritage. We need heritage plus science, sir. That's how we are born. That's how we are stick to. That's how we want to go, sir. Thank you.
Yeah, I agree with you, but I agree with his point also. He's talking about pure
Yes, sir.
sciences and putting knowledge. So we both are talking about engineering and the possibilities that have come up. So these are two different point of views. So well taken. Yeah, thank you.
Okay. Dr. Rintunath, you
Yeah.
want to share something?
Right. See, I would like to reiterate here the theme of National Space Day. If you see, it starts with touching lives
Yes.
before we actually touch moon. So when it is touching lives, we need to see the stakeholders here. Who are the stakeholders? If we say that, there is with the National Space Policy, there is a group of stakeholders who will be maybe the startups, who will be then the whole ecosystem, which will be supporting and building this R&D and the further development for the launching of rockets and satellites. A great deal of space economy is concerned, and whenever you have a payload, we have the capabilities of having higher taking payloads, and that's definitely is going to contribute to the space economy. Apart from that, as I said, the startups. Apart from that, what is more important is the stakeholders who are the common people, the general public. So we need to understand the aspiration of public to understand the space of exploration. See, space exploration cannot be done only because we want to go deep space or we want to go for an interplanetary mission. Of course, that's one of the important requirements because we have the capability of having those, interplanetary missions. But it is important that we need to understand the aspiration and linking up. Unless we link up, unless we have a greater understanding of science and aspiration for that, to be a part of that journey, it is going to be, one point agenda only, which is not, fortunately, which is not. Our case is much more stronger. We first build up our case. If you see, Dhanlakshmi ma'am's presentation, it was all about the space exploration, about the people. Is a farming, is a weather forecasting, it is a mitigation of natural resource disasters. So we have already touched upon those lives. It's not that our space exploration is based on only to show our ability to go to interplanetary mission. No, we have not done it. Maybe NASA might have done it, but still they have their public perception of getting into this the facts whether we should go to Saturn and whether we should send another mission to Jupiter. India have not done it. We have started with this, launching of satellites. First, we did launching of satellites for communication purpose. Then we have done for surveillance purposes. We have the geostationary satellites. We have the polar satellites. We have the ability to launch multiple satellites at a time, and that's what is a space economy concerned. And now we have established our capability to go to moon and even the interplanetary. So we need to understand there's an entire ecosystem. It's not the standalone only ISRO or ISRO's other subdivisions or the startups. It's the whole nation is involved. And we need to understand that how to make them even further more involved. So National Space Day give us an opportunity to linking those everybody, especially to the students, to understand why we celebrate it. We need to talk about Vikram Sarabhai, the father of national space, Indian space. We need to talk about those people who have contributed enormous to take India to the next level. We need to talk about our success stories, and we need to talk about those things, the events like these, National Space Day. As I said in my initially, that we have to target those young minds in those special times when we have a success, we have an event, say solar eclipse. I think Dr. Sachin said about solar eclipse. They actually did a marvelous, this commercial flight. And maybe Dr. Sachin would be knowing that from Vigyan Prasar, we did the same thing, but with Indian Air Force. I was in AN 1332 aircraft, and this entire ramp is open in front of me at 25,000 feet, and we chased it. Now we did not for our own glory, but we actually shared this entire journey, the data. It was live telecast by the Doordarshan, and we have millions of students which were linked up with us. So this is what is important. We need to have this aspiration, with us, especially the aspiration of the students, their motivation. See, they will be motivated when they see the success. We should be able to talk about those success stories in a more, understandable way. And also we need to talk about those people who have given us success. So this is what the Space Day is all about. Yeah.
Yes, we deeply appreciate the wealth of knowledge and experience you shared with us today. So I would say to all the panelists, your insights were truly enlightening. So today we explored how these achievements have paved the way of new opportunities, especially for our youth who dream of reaching for the stars, and discussed the career possibilities in space sciences. So the impact of space technology on our daily lives and what the future holds for Indian space exploration. Now, coming to the Q&A segment, dear esteemed panelists and our attendees, we have received several questions from our audience that we are eager to address. To start, we will direct our first question. I guess it would be comfortable if you will be raising the hands, and I'll straight take the questions to that particular panelist. So the first question coming for the student named Vansh N. Bhagat from LT College of Engineering, Ahmedabad. And the question is, why ISRO conducted the relaunch of lander of Chandrayaan 3 after it landed on the surface of the moon? So I guess I'll pass my question to Brahmastra Aerospace. Yes, Dr. Kuppusamy, Professor Kuppusamy. So I hope you can answer the question.
Could I have the question again, please?
Yes, sure. The question is, why ISRO conducted the relaunch of lander of Chandrayaan 3 after it landed on the surface of the moon?
It is because of on Chandrayaan 2, what happened is we sent our lander in a box where we landed, where the lander is working, where the box has not opened. So that's why we sent the Chandrayaan 3 with a lander under, a rover.
Okay.
Right. The Chandrayaan 3 launched very well, and we succeeded it in a very better way.
Okay, great. So I guess we have Dr. Sachin Bhambo also to make this discussion more clear. So
Yeah, I
Dr.
think, on a National Space Day, when we are celebrating our landing on the moon, when we became the first nation to land a lander on the moon, this question is really important and, needs to be answered the way it has to be, because this is a feat that we achieved. We were not able to land our lander in the second mission to called Chandrayaan 2. We just had an orbiter and our lander was not successful, and we got successful in the third attempt, Chandrayaan 3. We had a lander, and then we have Pragyan rover, which actually touched the moon, and we were able to walk on moon, and that's the reason we are celebrating it. So people also need to understand why is it so important. Moon is now the next destination to which all nations are looking at. And if a nation is taking space missions or interplanetary missions, there are 6 stages. First is flyby, then orbiter, then you have a impactor, and then you have a lander, and then you have a return mission, and then you have moon mission. Now, if you see that ISRO was just a child, it was just born in 1969 when some other nation, because of the Cold War, had already landed people on the moon. So we were just taking birth when people had landed on the moon, and we have so nicely covered that gap. We have just mitigated the difference between the two nations, the two top nations, by landing our lander on the moon just in a period of 55 years. That's amazing, and that is the reason we are celebrating it. And we are the nation who actually discovered there was water on the moon. See, people have landed on the moon, and there is no science yet, no papers published. Yes, though India was the second one to publish the paper, as Professor Sandeep was talking about, we get delayed in publishing our papers. Although we did the discovery of hydroxyl molecule on the moon, but paper was published first by US, though the discovery is still Indian. So we discovered the water on the moon, and moon is the next destination. Our Prime Minister has already announced that by 2035 we'll have our first Antriksh station, and also 2040 there would be human landing on the moon. So you can see that we are just covering the distance so fast, and people are looking at us, the world is looking at us. We have become one of the top 5 nations who have touched the moon, and probably the returning sample mission moon will also be happening at some point of time, and that is the reason we had to send Chandrayaan 3.
Thank you. Thank you so much, sir. I hope our audience get a very better clarity over the questions raised by them. Now, the next question coming from the student named as Balasundaram. And the question is, why our country will not set up a small research space station on moon like Antarctica Research Center, or like USS space station for migration on moon? So, just the group of panelists, just let me know who can answer this question so well, so the audience can have a clear insight about the same. Dr. Sandeep, would you like to answer the same?
In Antarctica, India is doing very well. 1980s, we had Moitri stations, we had then Sumachar place, and in fact, the Bharati more recently. And so I think Antarctica, we already have some facilities from where we take data from space, and particularly in radio. Right now, we have no optical telescope there, and that is one thing. But we could have also flown balloon from there and get the data from the southern hemisphere. The important part is the space station. Space station, India is already planning, and within 20 years or so, India will have its own space station. As you know, that this particular international space station is going to be junked very soon, and China is already having their own space station. We are going to have our own also. There is no alternative to that. In fact, we are going to do it, and this will be there within 20 years. One thing only I want to add, that on the one hand, that we are projecting the 2040s or something. By that time, the Earth is going to be another 1 degree hotter. Global warming, environment. So I would request that the people who not only looking at those who are pointing at this space, they should also think that the Earth is also a space object. It is hanging in space. And take it seriously. And the temperature has gone up by 1.2 degrees. Deforestation is large. Temperature is global warming is within next 5 years, things will be tipping off. 2023, temperature went up by a large number. As you know, 2024 already the hottest country, hottest year. So space is fine. I'm not anything negative, but I'm saying that you have to see the whole thing holistically, and not only the people. We should not think anthropocentrically. We should not think about our people or making colony. We should think of the whole Earth. So our main goal is to save this Earth, then only we go to space. So next, whoever is projecting that 2024, we are going to go to space, maybe half of our country will be underwater. I'm saying. So this global warming has to be challenged with equal amount of importance. So everything is fine. I have no problem.
Okay, thank you so much, sir, for sharing your views. So the next question coming from Raj Kumar Thakur, Sri Satya Sai Institution of Higher Learning. And the question is, with increasing light pollution, how challenging is it for Indian observatories to capture signals from space, and how these challenges are overcome? So,
Yeah, I think I would like to answer this.
yeah, sure, sir.
Okay, so answer is very simple. Yes, it is becoming very difficult because of the light pollution that cities are causing. But then, you have an Apple phone in your hands, and that has a wonderful technology of taking regular pictures, continuous pictures, and stacking them. We have done this now with telescopes. So it has now become possible that, I can put up a telescope even in Delhi and enjoy deep sky objects with a particular telescope that stacks online images. Now, one thing that you have to understand, whatever light pollution, however you increase, as soon as I cross 1500 meters, that is the first layer of the clouds where it is formed, and I set up an observatory on a height, there is no problem with the light pollution, even if the light pollution is directly below me, because the reflecting medium, which is the cloud, is lesser. So, We can put up observatories. We have an observatory at Helle, which is one of the top places on the earth, one of the top places, one of the highest places to have observatory on. And there is a huge possibility of putting up observatories. On one hand, where light pollution is bringing these problems, there is a regular solution coming from technology as well as strategic location of observatories. And that is how, the research can go on. Telescope is always one of the oldest remote sensing devices and one of the devices that makes everybody interested in it. So I'm sure observations will go on. Then infrared telescopes are next in thing. And we know, as Dr. Sandeep was talking about James Webb Telescope, it is a possibility. And finally, it is the best to put a telescope in space. Just take them to International Space Station. We are going to have our own space station. Even a small telescope can do wonderful discoveries. We already know about L1, L2 points. So there are a lot of possibilities for telescopes. I don't think that anything problematic will happen. And I would like to invite Dr. Patrick Miller, because he does wonderful work with telescopes. He can add to what I have already answered.
Yeah, so Dr. Miller, do you want to add something to the views shared by Dr. Sachin Hamba, sir?
Well, it certainly is true that that students have access to telescopes, particularly the internet. The idea of putting one on the space station is something never occurred to me, and it would be quite exciting. There are also telescope networks around the world that are integrated. I forgot the name of the one that does this, but there's an organization.
iTelescopes
that are integrated, and so they're collecting data from all areas of the globe, and so they can take advantage of good weather in one area and integrate those observations into single observation or composite observation that they wouldn't be able to if they have significant light pollution or atmospheric conditions that are interfering on a particular day.
Yeah, thank you, Nia.
Yeah. Okay, thank you so much, Dr. Patrick, so for sharing your, insights and views and for making the audience more clear about the questions raised by them. So the next question is from Stuti Bhatia, and she's from Hansraj College. And this question, I hope, will be better if answered by Ms. Dhanulakshmi ji, because this question is, how do you see women contributing to the space sector? So it would be great, Dhanulakshmi ma'am, if you can share your views over this, being a female, and how you can, empower women over the question stating that how women can contribute to the space sector.
Thank you, Neena. This is a very relevant question because India has been encouraging female participation in all the sector, including space sector. You won't believe. Our Ministry of Earth Sciences have the space station station at the Antarctica called Bharati, and the earlier version, where I have conversed with scientists who were women who stayed in these stations, Bharati station, for 6 months, and they come back with positive reports that they never face any discrimination or any practical problem while their stay at the Bharati station. So similarly, space also is an area where women can contribute a lot, and they have been doing. Have you seen the composition of the Chandrayaan team? Because most of the scientists who have contributed their might in those teams are women. And we do have a rich repository of women power in the scientific sector. And this trend is going to increase but not decrease. And you won't believe, we have a separate scheme which promotes women in STEM field. Like, right, we catch them when they are early. We have this Inspire Manak scheme and various scholarship scheme, Vigyan, Vidushi, Vigyan schemes, where we pick up children, girls, when they are young in their school days, middle school or primary school, and we start grooming. We provide them training. Our people go and train them. We have a National Innovation Foundation which trains these people in innovation. Whenever I frequently visit these innovators and discuss with them, I find a lot of women, girl children are very actively involved because government of India has given special policies and incentives to women. We have schemes through which we fund children's education in STEM programs. We have a
Thank,
separate wing in DST.
thank you.
Okay,
Thank you
so
so much,
Neha,
ma'am.
I think, as far as ISRO is concerned, all the major missions starting from Mangalyaan to Chandrayaan 2 and 3 have
Yes.
been spearheaded by women. They were directors of those women, those missions.
Right, right.
And I
And sir,
think
yeah,
ISRO believes much more. I can take names, Ritu Karidhal, Nandini Harinath, then Muthaiya Vanita, and then Srisha Bandala, Momta Datta. She was Agni 4. So I think from aerospace to defense to space, women are everywhere. And I feel that, Indian space sector talks about lot of participation of women in every form and every way.
yeah. And
Thank
so
you.
one more important point that the beauty of moon is also considered by the beauty of women also. So that is the main thing that we need to highlight.
Yeah,
Okay,
and I would
so
also like to add Sunita is right now, a person of Indian origin right now stuck in space. So, we
right,
wish her recovery back
sure.
home journey very soon and safe journey. Yeah.
Yes. So I hope that will be the last question that we'll be putting for today. Now, the question I hope that can be answered by Dr. Sirish Padikonda. So basically, artificial intelligence and automation are transforming industries globally. So, how do you foresee these technologies impacting the future of space exploration? And additionally, does Skyroot have any plans to integrate AI into its operations, basically? So, sir, can you share your views with us? So, please unmute yourself. Yes.
Certainly. Yeah, before to that, in continuation to the previous question, so Skyroot has a Kalpana Fellowship program where we encourage the women students as to participate into the program. While studying, they still can be part of this program and they can work in the rocket industry. Yeah, I just wanted to highlight that. And coming to the AI in the space sector, this is something quite interesting because AI is all about having data and analyzing it and giving the right solutions for us. And we really would like to have this into the designing, the designing of the rockets and everything. If that happens, the whole industry would be revolutionized, and also the way how we can think about the new solutions that would be going into the future. Okay, so some of the questions which you have asked for, by the students, can India envision to have an outpost on the moon or something such as that? And already there are a lot of activities which are happening, and India is being a part of Artemis Accords. And Artemis Accords is having already a lunar gateway, and also they have a lunar outpost, and also they have three different locations. So we need to understand all those things. And there been like several companies which are participating into it, and huge grants which has been awarded by the NASA, or even the contributions from the ESA and everything happening. So we as a country just started, we signed the Artemis Accord, and moving forward, any contribution towards that will also an possibility for all the Indian startups as well as government to participate into that program and actively engage ourselves into that. And coming back to AI, okay, having all this data, which practically we haven't seen what could happen in that particular atmosphere and all. Okay, that can be analyzed by this AI, and the design solutions derived out of that would accelerate the whole process, and that can skim down the timeline what we have. Yeah, that would be very interesting, and we are looking forward. But apart from that, like various other solutions where we use AI, but not on the rocket developments, which is what we would like to see in the future.
Okay. So thank you so much. Thank you so much, Dr. Sirish. So apart from that, as we conclude this enriching discussion, I would like to express my deepest gratitude to all our esteemed panelists for sharing their valuable insights and to our audience for joining us today. So this discussion has truly highlighted the incredible strides India in making in space exploration and education. So to our audience also, thank you for joining us in celebrating National Space Day 2024. And let's continue to push the boundaries of space exploration and education, inspiring future generation to reach for the star. So any message to the panelists, I mean, if you want to, pass on your message to our lovely audience so that they can have this wonderful message as a memory. So anything you would like to give from your side?
Yeah, I think I would like to repeat what Richard Brasnan had said, that only meek are living on the earth, rest of us are going to space. So let's be ready. So I want to go to space, and I hope everyone wants to go to space, and we are already in space, living on Earth. Look forward to that.
Great, great. So as we explore the
I think
universe,
Shirish wants to say something. Yeah.
Yeah.
yes.
So, Sachin, as you have asked before, like, one of my, classmate from ISU alumnus, Vikrant is,
Vikrant, yeah, he's working. Yes,
yeah, he's colleague of yours. And he already mentioned like your keenness towards launching a satellite, and we are looking into it. And definitely, I, already have invited Vikrant and extended that invitation to you as well for our launch.
Thank you
Like
so
I
much.
said.
Thank you so
Yeah.
much.
Thank you, thank you, thank you so much, everyone. We also explore the limitless potential within ourselves and let us continue to reach for the stars as a nation united in the quest for knowledge and discovery. So, here with that, we conclude today's session and wishing you all a wonderful day ahead. And yes, starry nights till the time. So, Jai Hind, Jai Bharat. Have a great day. Bye bye.